In this module, I bring the life table methods to bear on fruit fly data using active life expectancy model that is covered in Chapter 8 on human demography, in the sections concerned with human disability. The specific example I present here involves the use of a behavioral criteria as a biomarker to dichotomize the life course of individual fruit flies as either healthy or unhealthy. A biomarker of aging is a behavioral or biological parameter of an organism that will predict future functional capacity or mortality risk better than using chronological age as a predictor. Behavioral biomarkers of aging are important because behavioral changes with aging and thus behavior itself can be used as an index of aging. Moreover, any intervention to alter the chronological course of aging must be assessed behaviorally to evaluate the impact of the innovation on the quality of life. While monitoring the behavior of male medflies throughout their lives, my Greek colleagues Nikos Papadopoulos and Nikos Koulousis discovered a behavioral trait that is unique to older geriatric flies in general, and particularly to individuals that are approaching death. This trait was termed supine behavior in accordance with the upside-down position of the temporarily immobile flies. Supine males lie on their backs at the bottom of the cage, appearing dead or moribund, but these flies can right themselves either spontaneously or after gentle prodding. And it is clear that they are very much alive and moderately robust when they show walking, eating, and wing fanning behaviors, much of which are indistinguishable from similar behavior in normal, that is, non-supine flies. An event history chart showing the age patterns of the supine behavior for 200 male medflies revealed a distinct association between individual lifespan in both the age of onset and the intensity of this behavior. Note here age on the x-axis and survival on the y-axis, with a horizontal line depicting the lifeline of individual flies and shaded tick marks indicating the ages when they exhibited supine behavior. Supine behavior in many flies begins to occur about 2 to 3 weeks prior to death, and therefore the period of its occurrence closely follows the cohort survival schedule. Supine behavior seldom occurs in very young flies, where young flies are defined as less than 25 days, but frequently occurs in flies that are over 50 days old, which are ages at which the mortality rates begin to increase substantially. More importantly, the major patterns were not age-specific, but rather time-to-death specific, as they tracked inside the outer edge of the survival curve for this 200-fly male cohort. The event history chart helps identify 4 general principles of the medfly supine behavior. It is persistent in that it occurs on subsequent days after onset. It is progressive because the intensity increases with age. It is predictive because the onset and intensity are strong indicators of impending death. And it is universal because nearly all male medflies exhibited this behavior prior to death. These properties of supine behavior are consistent with the properties of biomarkers of aging. The data and resulting computations are summarized and analyzed in this table 10.5 in our book, with the columns labeled as follows. We have age interval, that is in 5-day intervals, number alive at the beginning of each interval, number of days lived in the age interval, proportion of flies in the age interval in the state considered unhealthy, the proportion of flies in the age interval of the healthy state, the number of days lived in the unhealthy state in the interval, the number of days lived in the healthy state in the interval, number of days lived in the healthy state in this and all subsequent intervals, and disability-free life expectancy at age X. Note that the summation of the columns 3, 6, and 7 represent respectively the overall life expectancy of 62.8 days, the fly days in the unhealthy state, which is 11.5 days, and the active or healthy life expectancy of 51.3 days. In other words, around 18% of the average male medfly's life for this cohort was spent in the unhealthy state. The schedules for total and unhealthy lifespan in these flies are visualized in this figure, with age on the x-axis and survival on the y-axis. The outer curve shows the total survival, the inner curve, the active life expectancy, and the shaded area between them as the number of life days spent in the less healthy, that is to say the supine state, when they were experiencing supine behavior. This model provides another example of an application of concepts and methods developed in the context of and for the analysis of human health that has a direct application in the analysis of health in a non-human species, in this case fruit flies. This ends the third module in Chapter 10 on Applied Biodemography.